A few years ago, I bought a GH1440W lathe from Modern Tool. The chuck on it actually ran pretty true right out of the box, usually showing about 2 or 3 thou run out. That was good enough for most of what I did, but sometimes I wanted it to run a little better. I considered several possible methods for correcting the runout, but the ideal solution is really to make the chuck adjustable. That way I can correct the runout for whatever workpiece I happen to be holding. It's well understood that the scroll in a universal chuck isn't perfect, and your runout can vary depending on the diameter you're holding. So, I'm looking at the guts of this thing for the first time and realizing how many features there are already machined into the chuck body that's kind of in the way of where I want to put the set screws that are going to adjust the concentricity. But maybe I can sneak some in here and here. Next, I need to figure out which diameters actually locate the chuck body on the back plate. This boss is about 5.117 and a half, and this bore is about 5.118 and a half. About a 1 thou difference, so we've got a pretty good candidate right there. Checking this other pair of mating diameters, I can see there's about a 16th of clearance, so they're not going to need to be adjusted. I decided it would be easier to modify the spigot on the back plate than it would be to modify the bore on the chuck body, because the work holding is built right in. You just attach it to the spindle nose, and you're ready to make chips. But before I machined it, I wanted to see how concentric it was from the factory. Not bad, maybe half a thou run out. Even though it was an incredibly short cut, I wanted to use the automatic feed for a perfectly consistent finish, so I adjusted the feed rate all the way down to the lowest available setting. With near catastrophic results, I recommend feeding away from shoulders, kids. It's a much better time. I wasn't sure if the chamfer on the chuck body was going to be big enough to accommodate the fillet left by the turning tool, so I had to do a little test fitting. Looks like there's still a little bit of a gap. I'm gonna have to adjust the tool so I can get a little bit deeper. That looks a little better. Next, I wanted to take the moving parts out of the chuck body so I could make a detailed model and assembly in Fusion 360. This let me verify that there was going to be room in the existing material for the modifications I wanted to make, and I also used it to generate the 4-axis toolpaths for my Tormach. The scroll doesn't seem to want to come out with those jaws still in place, so I guess I'm going to have to put this pinion back in. I wanted a pair of pins to help me orient the parts in the 4th axis, so I had to fire up the TL2 to make those. My first attempt at using the pins with a parallel to dial in the orientation of the backing plate was a bit frustrating because there was too much clearance between the pins and the holes they were installed into. Eventually, I came to a workable arrangement with a couple of parallels balancing on the pins and some grease sticking everything together. It definitely sounds a bit janky, but it actually worked out pretty well. Right here is where I decided to turn off the coolant so that you could see the cutting action a little bit better. That's a 3/16 carbide tip drill going into cast iron, which is a bit of a self-lubricating material, so the coolant isn't quite as critical as it might be for cutting other materials. Weird noise. Probably not important.
So it looks like one of my holes that I drilled to accept an anvil broke through into the alignment screw for the cam locks on the other side. It's through into this little M6 alignment screw hole, and you can see that screw, I'm not sure how well that's going to come through in the video, but that screw doesn't go all the way down anymore if that pin's in the way, or if I retract the pin and put that screw in the rest of the way, when I'm actually adjusting the concentricity of the chuck, that pin is going to be pushing on the thread, mashing those threads, and then I'll never get that screw back out of there. I think I'm probably just going to end up shortening that screw a little bit right there so that they don't interfere with each other. So I've got all of the pins that I made installed in the corresponding holes. I just put them in with a little dab of grease so that they kind of vacuum lock in there. You can see this one here really close to the edge of this cutout here for the pinion. So got away with sneaking that in there and not breaking through the wall, which would severely weaken it. I'm going to have to use this little set screw down at the bottom of that hole, which will provide a hard seat for that hardened pin to sit on, and that's going to be a lot better than having it sit on a little bit of soft cast threads in that hole. I guess I'm a bad YouTuber. I didn't take any video of machining the chuck body until I was ready to tap the very last hole, which I'm about to do. So there we go. Last hole tapped. Those pinion holes are at 120 degrees. These screw holes are at 90 degrees, and they have to fit in between. But then these holes over here have a lot of room. I wasn't too worried about them. But these ones were so close to a bunch of other holes, they're not evenly spaced. I had to shift the two of them 1 degree in this direction and get this hole a little bit further away from this hole so they wouldn't intersect. And in order to make sure I didn't get confused and shift the hole in the opposite direction from the chuck plate, I just gave myself a little red dot right there, and I put a matching red dot on the chuck plate, and that helped me keep them straight. So, time for a little test fit. This is the designated number 1 hole. You may be able to tell from the minuscule little red mark. right there. And this is the number one pin. Again, little red mark right above my finger. Camera's having trouble focusing, but that's it. So those correspond to each other. And if we drop a couple of these screws in so that we know it's somewhat aligned, then I should be able to look down the screw hole. It's got a little bit of wiggle there. I should be able to look down the screw hole and see that the pin lines up pretty dang well with the hole. And I don't know, you can't see it really well on the video, but that pin is bang in the center of that threaded hole. And so is that one. And so on. And of course they are, because it was made by CNC machines, and CNC machines always automatically make everything perfect with no effort or skill on the part of the CNC machinist, right? Sweet. So all there is left to do is put it back together and take it for a test drive. Fire in these pinions. Figure out which side goes where. It's like this. Relying on my red dots again. About like that. And then our one short one is going to go in our one compromised hole. Pretty smooth for a cheap chuck. Okay, it's possibly slightly weird to be this excited about set screws, but I am kind of excited about these set screws because they came early from Amazon, and they are the finishing touch that I need to put on the Set True 3-jaw chuck mod. Look at them. They are decently well formed. The dogs are a little bit uneven on the end, not perfectly flat like in the picture on Amazon, but I do think they will be functional. Stainless steel, just because that's what was available M6 by 1 by 16 millimeters long, which for a full dog set screw that gets you a 4 millimeter diameter by 3 millimeter long dog, which is going to be perfect for clearing the little shoulders and ledges and everything that these need to reach the anvils that I installed on the backing plate earlier in the build. Cool. Shiny. Okay, set screws are installed, parallel bar clamped with the use of the master 0 tightening point here. Tense indicator is indicating. I had to do a quick rough alignment dialing on this just to get it within the sweep of the indicator. You can see it's moving from, what's that, about 1 back to about -2. It's about 6 or 7 thou that this is out now, which is worse than when I started, if you remember. But that makes sense because there's a whole lot more slop in the pilot between the clamping plate and the chuck body than there used to be. So until we make it accurate, it's going to be much less accurate than it was. At this point, it's kind of like dialing in a 4-jaw chuck. So we're just going to look for the point at which it is softest on the dial, which actually I think is where I'm at right now. That's hardest on the dial, that's softest on the dial. And we're going to pull the chuck and through that the parallel bar back towards the dial indicator with that set screw. So whoa, that moved pretty quick. Down to a couple of tenths already. Or is this thing not round? Seems to be flopping around a little bit. So we may end up, I got a feeling that I may have loosened the screws in the front and the back that hold the body and the clamping plate together. This might be a little looser than they really should be. Maybe if oh yeah, I want to have a little bit left in it to bring it back to 0. Yeah. You don't want them tight, otherwise it won't move at all. What you want is just kind of, oh yeah, should have had quite a bit more in the back there. You just don't want any slack at all in them, and they had a little bit of slack in them. And there we go. That's a much smoother motion on the 10th dial. And now we ought to be able to, we're already down to 2 thou. Should be able to play the game a little bit more consistently. Playing with tenths is tricky. We're only within a couple of tenths now, which, I mean, is already way better than it has to be for kind of everyday use. Soft spot there still, just ever so slightly. Look at that. Just a quiver. Half a tenth maybe. And, you know, we might lose that half a tenth when we actually tighten up these screws on the chuck body and the clamping plate that tie everything together, but in theory, that is how accurate you can get a cheap import chuck to be, with a couple of mods and a little bit of patience. So yeah, off camera, I tightened up the the screws between the backing plate and the chuck body the rest of the way, and didn't actually make much of a difference. I'm still running about a tenth of concentricity. So I thought it might be fun to take a test cut on a piece of stock with the chuck dialed in. So I've got a little piece of 4140 here that I'm just going to cut from one end, turn around, cut from the other end, see how well it matches up in the middle. I already know it's not going to be perfect because I did throw a dial on it and I could see that it was running out about half a thou compared to the so even though it's the same diameter as the parallel bar, the fact that it's not sitting in all of the jaws all the way back there is causing it to sit a little bit differently than the parallel bar was when it was sitting across the entire length of those jaws. So anyway, here we go. I was dialing about a half thou run out. Let's see what that looks like when we actually run a test cut. Very light cut with a very fine feed. And let's see what we get. It's seen worse.
Overall, I'm really happy with the way this project turned out. Let me know in the comments if you like this method of getting lathe chuck concentricity, if you hate it, if you have other methods you like to use, and especially let me know if you decide to attempt this mod yourself. Throw me a like for the algorithm, subscribe to my channel if you want to see more videos like this, and I'll see you next time.